Okay, now that we've had a chance to define ratio and proportion, we want to go into the subject of variation. What does that mean? Well, we're going to define the first one called direct variation as a direct variation means that two quantities are related in such a way that as one increases, the other increases, or uh, similarly, if one decreases, the other decreases in direct proportion to each other. We would say that y varies directly as x, then we're going to use the model y equals k times x to model that situation. So as an example, let's say we're talking about the distance d that a spring will stretch. And we say that distance d varies directly as the force applied to the spring, right? So we've got a situation in which we have a spring. All right, so here's your spring. A spring attached to a weight. Right? And the weight, of course, at the end is our force, F, and the distance that the spring stretches is D. Right? So we say that if we use a force of 12 pounds, then the distance we're going to get is 6 inches. Right? So, okay, 6 inches for 12 pounds. The question that's being asked here is, well, what would happen if we wanted to stretch the spring to 10 inches? So we wanted to stretch out this spring a bit more. Pardon me. And we wanted that spring to stretch out 10 inches this time. What force, F, is required? Well, this is a job for our direct variation because the distance varies directly as the force. So we're going to set up a model similar to this one. We're going to say, well, distance, if distance varies directly as force, distance is equal to some constant times the force, right? And we know that right away that the 12 pounds is required for 6 inches. So we can use that given information that 6 inches is equal to our constant times 12 pounds. Right? So what is our constant? Well, we divide both sides by 12. We find out 1/2 is equal to our constant k. So now we know that the distance is always equal to 1/2 times the force F. All right. So in this particular spring, what happens? What kind of force is required if we want to stretch it 10 inches? Well, we're going to take 1/2 times whatever force is required to make that happen. And in this case, that requires that we would multiply both sides by 2. Right? So 2 times 10 then would equal 2 times 1/2 F. That cancels out on the right-hand side there, but on the left-hand side we get 20 equals F. So we require, see if I can spell that correctly today, 20 pounds of force. 20 pounds of force to stretch that spring 10 inches rather than 6 inches.